and you will get a link that I will send to your email address by tomorrow morning that shows you how to watch the session.
Okay.
What you watch is actually whatever my screen is showing with both audios. That's what you get to review.
Okay.
Okay. So let me set this up to where I can put this one on one side and this one on another. And this is my drawing tablet. Whatever I write over here, you should see.
Yep.
And I can draw figures and shapes and everything. Just like if we were in person and I had a pencil and paper. There really is nothing lost at all by being online. And in fact, there's a lot of things that are more advantageous, the fact that we're online.
Yeah.
Like being able to record the session. Also, I have tons of geometry problems in my database. I've been doing this for 7 years, and usually the student sends me a picture of their geometry problems, and I save all of them. So if you needed, a database of problems to work on, I can always provide it.
Oh, cool.
Although it works best when you send me the problems specifically that you're working on.
Okay.
Okay. So let's take this one on the left.
Okay.
What is that thing?
So that is a pentagon. I would like to figure out the area of this.
Yeah, it's a regular pentagon.
Yeah.
And what's the area general? The way you should pretty much start out all math problems is write the general formula for the area of a polygon.
Okay.
What is it? It's 1/2. What's the rest of it? Do you know?
Isn't it number of sides?
Well, there's that little a, which is the
apothem. Apothem, yeah.
Yeah, I pronounce it apothem. I don't know. Does your teacher say apothem?
Yeah.
Really?
Is it?
Wow,
Yeah.
I've been mispronouncing it for 7 years? You're kidding. Wow, okay. And then the side length is next, and the number of sides. There's your area formula. Now,
Okay.
it can also be written in a slightly different way, which sometimes works a little bit better. Instead of the side length times the number of sides, I'm going to use perimeter, which is equal to the side length times the number of sides, right?
Yeah.
And this is only the formula for regular polygons.
Okay.
Okay, it's not, you can't put just any old polygon up there and use this formula. It has to be regular.
Okay.
Okay, well, we have most everything we need. We're going to use the top formula since it's easier. They didn't give us a perimeter. Had they given us a perimeter, I might have used the second formula.
Okay.
Notice that if they'd have given us a perimeter, I wouldn't have necessarily known S or N, but I don't need to. If I know the perimeter, that's knowing S times N.
Okay.
So the area is going to be what? Plug in everything for me.
Wait, dude. So
What's the...
you would have, so you have the apothem, which is 3.5, and then the side length is 5.1, and then there's 5 sides.
So there's your area.
Okay. So then after that, if you weren't given the apothem, how would you go about getting the apothem?
Okay, the most typical situation is where they would give you a radial line.
Okay.
Instead of the apothem.
Okay.
I don't know if I can force myself to say it that way after so many years of In other words, if they gave you this length right here,
okay,
say that that was 5.
Okay.
Okay? And they gave you still a side like that.
Okay.
Well, I can figure out what the apothem is from this information. In other words, what I have to do is draw that triangle. What's this central angle?
Would that be 90? Or?
No? What's the total of the whole thing around that dot? 360, right?
Yeah. Okay.
How many
So then divide that by
central
5.
angles are there if I were to connect all vertexes to it?
5.
Five of them. Right. In other words, you always have there's 5 central angles if it's a 5-sided figure. There's 7 central angles if it's a 7-sided figure, and so forth and so on. So the measurement of this has to be 360 divided by 5, which is 72.
Okay.
Okay? Now let's take this little triangle and draw a vertical right down the middle of it.
Okay.
So, and I'm going to draw this outside of the drawing just so you understand it. What's that angle right there?
Or that would be 36.
Correct. And if I know
And then we can
that
use
is 5, I know that's the
use
right
trig.
angle, so now you can use trig to figure out the apothem. What trig function how would you do it?
I don't actually know. I'm having trouble with that.
Okay. Well, what you want is the trig function that relates A and
Oh wait,
pi.
the sine.
No, cosine.
Or we have cosine. Yeah.
So the
Okay. Because we have
cosine
hypotenuse.
of 36 degrees would be equal to A over 5.
Okay.
Cosine of 36 is just a number. Get that out of your calculator. Multiply it by 5 and you'll have your apothem.
Okay.
Once you have your apothem, you can go back. Now you have the same information that this one had. You can go back and plug it into your master formula.
Okay.
But the key to all of it is that master formula. Got to know that, okay? And this is generally the only other way they might present this problem to you is to give you these radial lines. Actually, I guess I could solve this problem if I knew this was 5, huh? Because I'm still going to have this triangle down there.
Oh yeah, and you have the base as well.
Instead of the 5 being that would be half of it, 2.5. I could still solve for the apothem if I knew just the side length. As long as I know how many sides and the side length, then I can always calculate this central angle, divide it in 2 to get this central angle, and then use the appropriate trig function to come up with the apothem.
Okay.
They may not make it that hard for you. In other words, they may always give you the apothem.
Okay.
Okay. All right. Let's look at the other one we can see. Oh, yeah. In fact, let me just scroll down here. Here we're solving for x. What kind of triangle is that?
That's a isosceles.
Yeah.
Oh wait, scale.
No, you're right. It is. I didn't recognize it because they didn't draw it to scale. Doesn't look like an isosceles, does it?
No.
There's no way this side over here is the same as this side here unless it's an optical illusion. But we don't care. It's a right triangle. Mainly it's a right triangle. Now this baseline is what? That right triangle.
Hypotenuse?
Yeah. So what's the formula? The hypotenuse squared equals
It's
what?
a squared plus b squared equals c squared.
Yeah, well what's a squared? One of them is 6 squared. The b side is also 6. So x squared is equal to 72. X is the square root of 72. Do you know how to simplify that? You would lose points if you gave that as an answer.
Yeah.
You wouldn't lose all of them, but you'd lose at least a point.
I don't really know.
Okay, you don't do it with your calculator. In other words, the idea isn't to round it off to a decimal.
Okay.
The idea is to leave it in radical form, but simplify it. Well, I know that the square root of 72 can be written as the square root of 36 times 2. Same
Okay.
thing, right? And then that is the square root of 36 times the square root of 2. In other words,
Okay.
the square root of a times b is the square root of a times the square root of b.
Okay.
And now the square root of 36 is a 6. So whenever you have a radical, what you're attempting to do is factor it and have one of the factors be a perfect square number, like 36.
Oh, okay.
Okay, let's do a few of those.
Okay.
Simplify that.
Wouldn't that be square root of 6?
No, the square root of 32.
Oh.
So we need to factor 32. And we want to make
16 times 2.
No, actually not.
Or square root of 16 times 2.
Yes it is. Sorry. Yeah, my mistake. I don't know what I was thinking. Square root of 16 times square root of 2.
Okay. And then you can have that be 4 times square root of 2.
Correct. Now, let's say that you didn't see or know that 16 was a factor.
Okay.
Well, mainly what I'm looking for is to have a factor that's a perfect square number. Well, 4 is a perfect square number. So it's also 2 root 8. But then root 8 is not simplified. Root 8 is root 4 times root 2. So I get to release another 2. So now I have 2 times 2 times root 2, which gives you 4 root 2. Only it took an extra step, right? In other words, I had to do maybe an extra 2 steps to figure out the same thing that you got in 1 step because you saw that there was a bigger factor of 32 that was also a perfect square number, 16. But it isn't necessary to necessarily see that. You always are going to get to the correct answer even if you start with a lower perfect square number.
Okay.
Okay, now here's something else though. Simplify that.
Okay.
Factors of 10.
10. So
It's only 2 of them.
Okay, so 5 and 2. So square root of 5.
But neither of those is a perfect square number, right? In fact, I can't find a factor of 10 that's a perfect square number. So that is not considered a simplification. It's considered more complicated because it's 2 terms instead of 1. So square root of 10 is simplified. In other words, it's only not simplified if you can't find a factor that's a perfect square number. Well, here's my perfect square numbers. So I'm always looking for factors that are one of these numbers. Okay? So if I had the square root of 98, I can see 49 is a factor of 98. I'm going to make it the square root of 49 times the square root of 2. Which will turn out to be 7 square roots of 2. So in order to be able to simplify radicals, you really need to know your perfect square numbers, at least up through this point here. And even if I had a problem like square root of 200, well, I could do this a number of ways, but the most efficient way to do it is the square root of 100 times the square root of 2, because the square root of 100 is 10. So that's a one-step method, as opposed to 50 or 25 times 8. You know, 25 is a perfect square number also, but that would involve more steps to narrow it down piece by piece. All right, enough algebra. Let's get back to geometry. But as long as they're going to ask you questions like this, you do need to know how to simplify radicals. You know, unless their directions are give your answer to the 2 decimal places, then it's a whole different thing. Then you just stick it into your calculator and round off. But notice that square root of 2 is equal to approximately 1.41 and infinitely more numbers, right?
Mm-hmm.
So if I represent this irrational number by a decimal, I'm necessarily making it less precise. Because I can't represent it as a decimal. There's an infinite number of numbers, and there's no repeated sequence at all. So if I'm going to represent that square root of 2 as a decimal, I'm necessarily going to have to approximate it. And it's always better to not approximate if you can avoid it. So when you get into higher levels of math, they never have you give that as a decimal, just like they leave everything in terms of pi. You very rarely see somebody have to round that off, because where do you round? Even if I call that pi, that's not pi. That's rounded off pi. That's an approximation for pi.
Yeah.
So if you can, leave your answers in terms of pi or the irrational radicals. It's always best to do that. All right, let's take a look at this purple problem here.
And when I looked at that last night, I thought that was law of sines, but I'm not entirely sure.
Actually, law of cosines.
Oh, okay.
I think, let's see, I can't, maybe you can give me this information at the bottom. Let's see, I think it says angle A equals 72.3.
Yeah, and then
side B equals 46.3.
Hold on, let me pull it up.
And side C equals 40.8. I believe I have those right.
It's 45.3.
45.3. The other numbers correct?
Yeah.
Okay. Well, if I draw this triangle, and this is A, this is 72. Boy, I wish they'd use whole numbers just until, I mean, why do they use decimals? Seriously, I mean, there's no reason to make it more complicated. The essence of the problem is not doing the arithmetic. The essence of the problem is figuring out how to write the law of cosines for this.
Yeah.
Well, side B is this one, 45.3, and side C is this one, 40.8. When you are solving a triangle that is not a right triangle, you only use the law of sines and the law of cosines. You never use those on right triangles. On right triangles, you can always use just trig functions, like we did on that first one to solve for the apothem. We just used a trig function to solve for that half of the central angle. But these are different. These are triangles that aren't right triangles, and you have three pieces of information. Now, let's talk about the law of sines and the law of cosines. The law of sines is pretty straightforward, not hard to remember. And that is, within any triangle, this is true. There is a fixed relationship between the sine of an angle and its opposite side. So if we had a triangle where we had an angle and an opposite side, we'd always use the law of sines to proceed. But this triangle doesn't give us that. There's only two situations where you have to use the law of cosines to begin. That's when you have side angle side, which is this situation, and when you have side side side. That's it. Those are the only two. Only in those two do you not have an angle and its opposite side relationship. In other words, let me just put a number on here, 50. If I want to solve this, well, I know that the sine of 72 divided by 50 is the same as the sine of that angle divided by 40.
Mhm.
So I would be able to solve the rest of the triangle using just the law of sines.
Okay.
And always do that if you can, because it's the easier one than the law of cosines. Let's talk
Okay.
about the law of cosine, since that's what we have to use. But I should also add that on all problems that you have to use the law of cosines as the first step, you end up using the law of sines as the second step always. So
Okay.
anytime you're solving a non-right triangle, at some point you have to use the law of sines. But what you use to begin with depends on the kind of triangle it is. Since this is a side angle side triangle, I'm going to use the law of cosines. First of all, let me label this. And here's what the law of cosines says. It's actually three of them. I'm going to write all three of them real quickly.
Okay.
Just so you see the pattern. The pattern is everything because it's the same on all three. In other words, I've got one side squared equals the other two side squareds minus 2 times the other two multiplied together times the cosine of this angle.
Okay.
Which means b squared would be equal to a squared plus c squared minus 2ac cosine of angle b.
Okay.
And the third one, and you can use any one you want, but sometimes the lettering of you'll see in this case that it's going to make sense to use one of them only. What's the third one going to be?
Would it be c squared equals a squared plus b squared minus 2ab times cos c?
Yes.
Okay.
That's the pattern. Okay. So let's see. First of all, I'm going to try to solve for side A.
Okay.
So I'm going to use this one.
Okay.
Okay. And once I do solve for side A, then I will have an angle and its opposite side relationship, and I'll finish the problem by using the law of sines.
Okay.
Let me erase these two just to make some room. And let's fill in everything here. We don't know A, that's what we're trying to solve for. But we know B. And I'm just going to round these off. It's crazy that they use decimals. It really is. It's nutty.
Yeah.
It serves no purpose other than confusion. You still have to know the formula. Cosine of 72. Notice that everything on the right side of that equation is a number.
Mm-hmm.
There's no variable.
You can just math it out.
Yeah. In other words, you put that in your calculator, whether it's 45 or 45.3. I mean, I don't care. But just to explain it to you, I'm rounding them off. So A is the square root of that. Whatever number that is. We only have an hour, so I don't recommend we take it up with doing arithmetic.
Okay.
Okay. As long as you are certain you know how to get that. In other words, once you get it laid out like that.
Okay.
You can do that in your calculator?
Yeah.
Okay.
Yeah.
So once you get A, let's just say A comes, I'm going to guess here to save us some time. Let's say A comes out to be 50. Okay. Now let's finish the problem using the law of sines.
Okay.
Tell me what I should write next.
So we know angle A, and
so we know that, right?
Okay.
So let's start with that. Let's start with that relationship. The sine of 72 over 50.
Mm-hmm.
Well, what's the next thing we want to solve for? Let's solve for angle B.
Okay.
So I'm going to say the sine of B over 45.
Okay.
Now there's only one unknown here, and that's B. So I'm going to be able to solve for angle B. Although it's a little tricky, let's just go through that. So we get the sine of B equals to 45 times the sine of 72 over 50, and that's equal to the sine of B. So we get a number for the sine of B, but that doesn't tell us B. How do we get B? Got to take the inverse sine of that number.
Okay.
So let's say this number comes out to be 0.8. That's what the sine of B equals.
Okay.
Well, now, if the sine of B equals 0.8, and I'm trying to solve for B, I'm going to take the inverse sine of both sides. When you take the inverse sine of the sine, those cancel, and you're left with B. So in this case, B would equal the inverse sine of 0.8.
Okay.
That will be an angle. So assume that angle is 70 degrees.
Okay.
Now we have 5 parts of this triangle figured out, right?
Mm-hmm.
We've got all 3 sides, and we got 2 angles. So what's
using the law of triangles, you can find out.
That's the easiest way to get angle C. Don't go through and use the law of sines for the last part. Just add these 2 angles, subtract from 180, and you get something like 40. And now you've solved the triangle completely.
Okay.
Okay. Let me just talk about one other law of cosines that's a little more difficult. Let me give you a problem here. The other situation I said was when you had side, side, side.
Okay.
No angles. You always are given 3 pieces of information.
Okay.
Either you have side, side angle, or side angle side, or side, side, side. You end up with one of those combinations. Well, I got side, side, side. That means I have to use the law of cosine. Pick any side you want to start with in any of those 3 formulas.
Okay. So use c squared because we have that.
Yeah.
And then
okay, so I know that 6 squared is equal to what?
6 squared, 36.
Let's leave it as squared for the moment.
Okay.
What's the law of cosines going to do for the rest of it?
So it's going to be a squared, which is
the other 2 sides squared.
And then 7 squared. Yeah.
Excuse me. 7 squared, yeah. Minus 2 times 8 times 7 times the cosine of angle C.
Okay.
Now, there's only one unknown in that equation.
Which is cosine of C.
Right. So we're going to do it the same way. We're going to end up with the cosine of C equaling some number. Let's say this time it's 0.7.
Okay.
Now I'm going to take the inverse cosine of 0.7. Come up with that angle C. Well, let's say angle C comes out to be 70 degrees.
Okay.
I finish the problem using the law of sines because I now have an angle and an opposite side relationship.
Okay.
I should say I do the next step using the law of sines.
Okay.
In other words, using the law of sines will let me solve for either angle A or angle B. Once I solve for that angle, now you can use the law of triangles to solve for the third angle. But this step here is the key, where when you actually end up solving for the trig function of the angle, you have to always remember to take the inverse trig function. Let's talk about inverse trig functions for a moment.
Okay.
Sine of 30 degrees is 1/2. We always take trig functions of angles to get ratios.
Okay.
We take inverse trig functions of ratios to get angles. This is an if and only if. If the top one's true, the bottom one's true. If the bottom one's true, the top one's true.
Okay.
And this is a key understanding of trig, is that we take trig functions, whether it's sine, cosine, tangent, secant, any of them, we take them of angles always. And we get ratios. Sometimes we get whole numbers, but they're still ratios. And we are always, if we have to solve for an angle, we need to take the inverse trig function of the ratio.
Okay.
In other words, let's take the 3, 4, 5 triangle that's real popular everywhere. You've seen this 100 times, I'll bet.
Yeah.
That's a right triangle. Okay? Bet you don't know what this angle is. Because that's not a key important part of this right triangle. This is an important part of geometry because it's the smallest perfect Pythagorean right triangle. So you get it a lot in geometry, but nobody ever asks you what that angle is. Well, how would I get that angle? It's the expression. Remember, to solve for angles, you need inverse trig functions.
Okay, so we have, we have the 90 degrees, and then we need to find the one next to the 90 degrees. I think that's adjacent.
Let's talk about if we could actually use any of the trig functions, but I'm going to use, I know that the sine of x equals 3/5, right?
Okay.
Opposite over hypotenuse. So I'm going to use the inverse sine of 3/5. So that will give me the angle. That will equal x. I could also take the inverse cosine of 4/5. That will also give me x. I could also take the inverse tangent of 3/4. That will also give me angle x. Turns out that this angle is like 37 degrees. The side opposite the 3, that's rounded off. It's actually 36.9 something. And this one is 53. So a 3, 4, 5 triangle is a 37-53 right triangle.
Okay.
But we had to use trig to figure out this angle.
Okay.
I could also have used trig to figure out that angle, but it would be different ratios.
Okay.
All right. Let's look more at your problems here. Now let's see. We're scheduled to go to 6. Am I correct there?
Yeah.
Uh-oh.
I think.
Screwed it up here. We started at 5, right?
Yeah.
All right. I've seen this happen once before on Windows 10. It got confused when I did this, and now I'm not going to be able to get rid of it. And I can't click on anything either. Now if I can figure out what I did last time to solve it, I think I had to reboot. Let's hope I don't have to do that. Let's see what happens if I do a Control-Delete. Let's pull up Task Manager here. And let's end. Wow. Let me think here for a moment how I'm going to close out some of these. Let's see. If I want to close out, let's try closing out Journal, End Task. And I don't want to close out the GoToMeeting, I'll lose your connection, but I think I can close out Google Chrome. That's going to end the calendar. Now I should be okay. Now close out Task Manager. Okay, good. Now I need to open both of those. Sorry. Actually, I'm happy I figured out how to do it. Restore pages. I don't think I want to restore pages. Let me just pull up my email and get your next problem here. Yeah. And, oh boy. Oh, I hate this feature of... what's your last name?
Blank, B-L-A-N-K.
There we go. And now let me open my journal and let me put them side by side. Do you have Windows 10?
On my laptop I do, yeah. I'm still a fan of Windows 7 on my desktop.
I'm not a fan of Windows 10, let me tell you. I upgraded from Vista to Windows 10 just about a month ago, and it was the hardest upgrade I've ever seen. I mean, it was like learning a new
thing. It takes
language.
a long time.
There's a huge difference. Okay, so in this problem here, we're trying to solve for the measurement of arc LJ. Which arc LJ are they referring to? Are they referring to this one around here, or are they referring to this one right there?
If they were referring to the one going to the right, it would be LJR, or L. It
would be
LRJ.
Exactly.
So
it has to be the other.
Left.
If they don't specify, let's say this point wasn't here, then you automatically use the minor arc.
Okay.
Okay? But since they put a point there, you're right. If they meant this arc, it would have been LRJ.
Okay.
There is a formula. When you have two tangent lines intersecting outside of a circle that are both tangent to that circle, there's a formula for that.
Okay.
What it is that angle K is equal to 1/2, most of these circles are 1/2 relationships, of arc LRJ minus arc LJ. In other words, these two tangent lines divided up this circle into two arcs, right? Big one and a little one, and that's it. Well, how I know the angle K is 34 degrees.
Okay.
What's the relationship between these two arcs? I'm going to put LJ, I'm going to call it X.
Okay.
That's what we're trying to solve for. If LJ is X, what is LRJ?
Y? Or?
No? Let's call it something in terms of X. Because if I can come up with an equation that only has one variable in it, I'm going to be able to solve for it. If I put Y in there, I have no way to solve it.
Okay.
But what is Y relative to X? In other words, what is the big arc? The total, they add to 360, right? So if this one's X, what's this one?
X divided by 360?
360 minus X.
Oh, okay.
Okay. In other words, if I know that X plus LRJ equals 360, well then LRJ equals 360 minus X. So that's what I'm going to write here, 360 minus X. And now I can solve that. I've only got one variable.
Okay.
And that's what you want, is you want to be able to write the equation with one variable so that you can solve it. In other words, this becomes 360 minus 2x.
Okay.
The next step of this problem, you can go two ways. You can distribute the 1/2, and it distributes rather nicely. So there's no problem doing that. But I actually prefer to multiply both sides by 2.
Okay.
And the reason is that it immediately eliminates all fractions. Now I can solve that really easily. Okay. Well, if I distributed it first, I'm going to be fine in this problem because it'll be 34 equals 180 minus x, and I can solve that easily also.
Okay.
But what if it was 1/2 times 79 minus x? If I'm going to solve this equation, there's no way I want to distribute the 1/2.
Okay.
Because
Yeah,
that's going to give me a fraction there and another fraction there. So if this is my algebra problem, it's far better to multiply both sides by 2, immediately giving you this. No more fractions. So that's generally the rule I use for solving equations, is as I try to get rid of the denominators first step, and then eliminate the parentheses, and go from there. Okay? But this equation is huge right here.
Okay.
That equation applies, let me see if I can list all of the situations it actually applies. It applies to two tangent lines, like that, the ice cream cone. It also applies to two secant lines that intersect outside the circle. In other words, this angle, theta, is going to be 1/2 of this arc minus this arc.
Okay.
Same thing as before, right? Okay. It also applies when I have a secant line and a tangent line. In other words, there's my secant line, there's my tangent line. Same thing. This angle, theta, is equal to 1/2 this arc minus that arc.
Oh, okay.
Okay? So this is a very, very common formula that, boy, if you didn't know this formula, you would miss a lot of your geometry questions. Because so many of the circle questions are going to come down to subtracting the difference of the arcs.
Okay.
Okay. And there's one other situation that's worth mentioning right now, and that is if you have two intersecting chords like that.
Okay.
This angle theta is 1/2 of the sum of the arc from there to there plus from there to there.
Okay.
So it's real similar, but it's the sum of the arcs. And you also don't have the whole circle being represented there. Notice that these two arcs do not make up the whole circle. It didn't cover this part right there. And it didn't cover this part right here. But only reason I bring it up is because this general formula is very, very similar to this one, only it's plus instead of minus.
Okay.
And that's because we're intersecting inside the circle. So one way to remember it is if you're intersecting inside the circle, you're adding the arcs. If you're intersecting outside the circle, you're subtracting the arcs.
Okay.
And finally, there's this problem where you don't have a full secant line. It ends right there. And then you have a tangent line, like that. And that theta is to be solved for. Well, I don't have two arcs that are being intercepted. I only have one. Let's call that x. But if I extend that to make it a diameter, now I know what this arc is.
I have two arcs.
No, it's 180 minus x. Because that's a diameter, which means the total arc length from there to there has to be 180. So if the small arc is x, the big arc is 180 minus x. And then you can solve the problem because they usually give you that angle. In other words, if they give you that angle, then it's 40 degrees equals 1/2 of 180 minus x minus x. Now, notice, again, I've got only one variable, so I can solve for x.
Yeah. Okay.
All right.
So,
Let's look at
yeah,
more of your problems. I'm going over some of these rules because I know that you're going to be tested on them.
Yeah.
On everything I just covered. Let's see what else. Find each measure. Okay, this is a little different, but not a lot. Here you have a tangent line with a chord. Let me just do the basic one first. Okay? Let's say that's 80 degrees, the measurement of that arc.
Okay.
What's the measurement of the big arc if that's 80? Got to be
so that's going to be
280, right?
360.
Right. Well, that takes care of the whole circle, and this angle and this angle have to total 180, right? Because they're a linear pair.
Oh.
So what does that tell you? This has to be what? Half of that.
Oh, it'd be 40. Okay.
And this has to be half of that. So this angle would be 140, and this angle would be 40.
Okay.
Together they're supplemental, and these two add to 360. So again, you have that 1/2 relationship in there.
Okay.
So based on that, what's angle 3?
Your angle 3 is 40.
No.
Or wait, half of that, it would be 198 divided by 2.
Yeah, 99.
Yeah.
Okay, so here we're solving for h. How are we going to do that?
So we need to find the hypotenuse. So that's going to be, and so we have adjacent, or I'm really bad at that.
We got 3 things. We got this angle, we got that side, and we got h. So which trig function relates that angle, that side, and h? That's what you have to always determine.
It's either sine or cosine. I'm really bad at defining which one it is.
Memorize this and you'll never get them mixed up again.
Okay.
SOHCAHTOA. If you have an infected big toe, you're going to soak a toa. Got to have tricks to memorize stuff in math. They really help. It really does. Okay, so sine, the O is always over. Is always opposite in SOHCAHTOA. So sine is opposite, and there's a hidden over right there between, there's an over there, there's an over there, and there's an over right there.
Okay.
So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent.
Okay.
So what we have here is the opposite side to that angle and the hypotenuse. So, no, that's that one there. That's sine.
Opposite. Okay, yeah. That's right.
Sorry. So what's the equation going to be? Always start with the trig function. I know I'm going to use sine. What's the rest of it?
So sine equals...
Remember, you take sines of angles.
It's opposite of hypotenuse, so we know opposite, so it's going to be 10.
Sine of what? We need something following...
Oh, sine of 51, sorry.
Right, that's all right. Sine by itself wouldn't really mean anything.
Yeah.
Equals what?
Opposite over hypotenuse, so it would be
in this case,
10 over h.
Yeah. And there's only one variable there.
Okay.
Multiply both sides by h, divide both sides by sine of 51, and you'll have h equals 10 over the sine of 51, you can get that number out of your calculator.
Okay.
Okay? Always make sure you're in degrees. Be a little careful when you're using your calculator on Trig. What kind of calculator do you have? Is it a...
I have a TI-81, I think.
Okay. Okay.
Yeah.
Some of those older calculators will not immediately tell you whether you're in radians or degrees.
Okay.
So make sure you're in degree mode when you're doing these kind of problems. Because if it happens to be in radian mode, you're not going to get the right answer. The sine of 51 radians would not be the same as the sine of 51 degrees.
Yeah.
Okay. So let's look at the next problem. We're to solve for x. Okay. Can you solve for AD?
Oh, wait. Oh, okay, use Pythagorean Theorem and then you find that.
Yeah.
Okay, yeah.
Well, actually, hold on a minute. That doesn't appear to be, they haven't put the right triangle thing in there.
Oh.
So, do we know that's a right triangle? And if it isn't, can we still solve it? No, we can't. Unless we know the right triangle. In other words, if I give you, well, maybe we can. I haven't thought that hard about it, but if I tell you that's 10 and that's 14 and you don't know that's a right angle, there's no way to figure out the rest of it. Remember, you need 3 pieces. If it's not a right triangle, you need 3 pieces of information to solve the triangle.
Mm-hmm.
But I feel like they just accidentally left it off here.
Well, wouldn't, since D would be supplementary, wouldn't they be opposite interior angles? And wouldn't it be 90? Or am I wrong?
No, not really. This picture is completely different than anything else we've seen.
Okay.
And let me think about this for a second. If there's any way to solve for x without making sure that that is a right triangle. Let me think. Let's try some things, first of all, before I give up on it. If it's a right triangle, it's going to be an easy problem.
Yeah, I just use Pythagorean Theorem.
So what's this side here? Square root of 14 squared minus 10 squared.
Mm-hmm.
That side's x. And that 14 applies only to this middle line. And this line is 16. So once we solve for side AD, now we can apply the Pythagorean Theorem again to solve for x, correct?
Yeah.
Let's, again, not get bogged down in arithmetic and call that side 12.
Okay.
Okay. Now, apply the Pythagorean to the big triangle. What do you get?
Or so,
yeah, the outside triangle, the really big triangle, okay?
Yeah, so would it be 16 squared equals 10 squared plus x squared?
Not x squared.
Or,
what's this base right here?
Or so it'd be 12 or 8 or
12
AC
plus x.
Yeah.
And now again we have an equation with only one variable. We're going to be able to solve for x.
Okay.
Okay. Now let's look at that for a moment or two. We've got 6 minutes. How many more problems do we have here? Just one?
Yeah, just one, I believe.
All right, let's do this last problem, and then if we have any time left, we'll come back and look at this previous one and see if there's a way to do it without knowing whether that's a right angle. I don't think there is. I think you have to assume that's a right angle to be able to solve this, but I might be wrong. This last question's pretty easy. We can cover it real quickly. Do they want arc AB or do they want the length of arc AB? Let's do both.
Yeah.
They don't say what it is they're asking for here. The measurement, and there is a big difference. The measurement of arc AB is in degrees. The length of it is in units, inches or feet, whatever. If I wanted the length of arc AB and that was a piece of string, I would cut it, straighten it out, and measure it with a ruler.
Okay.
That's arc length. Arc measurement is totally different. The measurement of that arc is 45 degrees, the same as the central angle.
Oh, okay.
Okay? In other words, if I have a circle like this, and that's 80 degrees, well, this arc from here to here is 80 degrees.
Okay.
And the other situation is where you have an inscribed angle. That's an inscribed angle because the vertex of the angle is on the circumference.
Mm-hmm.
Those are the two main situations you're going to have to deal with, is where you have a central angle, which intersects an arc that is the same size, and you have an inscribed angle. If that's 40 degrees, this is 80. In other words, when you have an inscribed angle, it's always half the measurement of the arc that it intercepts.
Okay.
Okay? So the really important thing is whether you're starting at the center of the circle or whether you're starting on the edge of the circle.
Okay.
Now, they may have actually been asking for the length of that. And let's solve that real quick, because that's another common question they could be asking for. If they're asking for the length of this, this is a circumference problem.
Okay.
Right? What's the
so that would be,
circumference of the whole circle? What's the general formula?
so it's pi r squared.
Oh, 2 pi.
Or no, not pi r squared, it's diameter.
Now we know how to figure out the whole circumference. They've given us the radius of 12, so the full circumference is 24 pi.
Okay.
What part of the circumference are we looking at when we're looking at AB?
It's only 45 out of 360.
Exactly. So we're going to multiply that by that ratio.
Oh, okay.
Whatever that angle is, divide it by 360 and multiply your full circumference, and that will give you the length of arc AB in units as opposed to degrees.
Okay.
And the length in units is important on this radius measurement. Whereas notice that the measurement of the arc at 45 degrees had nothing to do with the radius. So if you didn't have a radius here, it would have to be what's the measurement of that arc. But the fact that they put the radius there, I suspect they meant to say what's the length of that arc.
Yeah.
And the length of that arc, you always, when they're talking arc length, go to circumference. And then figure out what part of the circle you're looking at.
Okay.
Hold on 1 minute. I had to close this program out because it was the one that hung. So Justin, is this the only session that you've scheduled so far?
Yeah.
Okay. I think your mom paid for this one. The first half hour was free. Second half hour she paid for. So you're definitely good to go. But if you want to, well, your mom knows how to make the appointments on my website. So you can always see my availability, and I'm sure you got finals coming up here in the next couple weeks.
Yeah.
The only thing I want to warn you of is that the closer we get the finals, the more booked I get.
Okay.
So don't wake up on May 21st needing a tutoring session and waiting until then to make it.
Okay.
Okay?
Yeah.
try to schedule it in advance just to make sure you get that block of time blocked.
Okay.
Okay? And I am, for the next 2 weeks, I am going to be available until 10. So
Okay.
you can schedule a 9 o'clock if you want.
Okay.
All right?
All right. Well,
All right, Justin,
you did.
like I said, I'll send you an email in the morning that gives you a link to go over this session if you would like to review it.
Okay. Yeah, sounds good.
It's a YouTube file, and it's in YouTube format, so you can pause it, fast forward it, rewind it, do whatever you need to do. It's actually pretty useful if you're learning. I mean, we went over a lot of geometry stuff here. In fact, we went over a lot of stuff in this hour. I would think that you would love to have a recording of this session.
Yeah.
Well, you'll have it, but it won't be until tomorrow morning. So
Okay.
also keep that in mind, is that you don't get the recording until the next morning. So if you had your test tomorrow at 7 a.m., you would not be able to get the benefit of reviewing that recording before your test.
Okay.
So you might want to schedule your session 2 days before your final instead of 1.
Yeah.
Just a suggestion. Nobody likes that because everybody wants to schedule it the night before the test because they think they'll retain the information longer.
Yeah.
Whereas if they wait 36 hours, it might not be retained for 36 hours. I don't happen to believe that. I believe that slow and steady is the only way to learn.
Yeah.
And hopefully what you learned here, you'll know not only 2 days from now, but 2 weeks from now. And if you do something regularly, not just cramming before tests, you're better off. You're actually a lot better off. You learn the material better.
Yeah.
All right, Justin, I will let you go. And the way you close out go to meeting is just by clicking on that X in the upper right-hand corner.
All right.
Okay.
Well, hope you have a good rest of your day, and thank you so much.
You're welcome. Bye-bye.
All right, bye.